Ancient people did die from dirty water. A lot. But the strange thing is how many of them didn't. They survived without knowing what a germ was, without chlorine, without water treatment plants, and without a single water quality test. Picture yourself in Athens around 400 BCE, standing near a public fountain. Water is flowing out of a clay pipe. People are drinking it. Children are drinking it. Nobody is boiling anything. If you believed the old story that everyone in the past drank beer because the water was poison, this scene doesn't fit. And yet it happened. So what exactly were ancient people doing? Were they just gambling every time they got thirsty? The answer is messier and more interesting than a single trick. They did die, often. But they also developed a whole system, some built, some biological, some cultural, to get water that wouldn't kill them. Most of that system worked by accident, and it still shapes the way we live now. The first thing to understand is that dirty water is not one thing. If you imagine water with mud, leaves, and a dead animal floating in it, ancient people avoided that instinctively. They had millions of years of evolution wired into their senses. Water that smelled like decay, stagnant ponds, or feces triggered disgust. Disgust is not a moral judgment. It is an ancient public health system. The feeling that makes you recoil from a swamp is the same system that kept your ancestors from drinking liquid sewage. An ancient person did not need a microscope. They just needed a nose. The first water quality test was a human face making a face. But here's the problem. The deadliest things in water are invisible. Cholera, typhoid, dysentery. These pathogens don't always change the color, smell, or taste enough to warn you. A glass of water can look clear, feel cold, and taste fine, and still carry enough bacteria to kill you. So ancient people could not rely on their senses alone. They needed something more. And they found it, slowly, over thousands of years, by noticing who got sick and where they got their water. That is why the earliest medical texts sometimes read like water guides. Hippocrates, writing in ancient Greece, told physicians to consider whether water came from marshy ground, whether it flowed from high mountains, whether it tasted metallic, and whether it had been exposed to the sun. He did not know bacteria existed, but he had noticed that certain waters were associated with certain diseases. That is not primitive medicine. That is observational epidemiology. Ancient people had a real vocabulary for water. They called some waters sharp or sweet, heavy or light. They believed that the best water came from high places, where it had not yet passed through human settlements. That belief was so strong that the location of a spring could determine where a city was built. Water was not just a resource, it was a foundation. To understand why some water was dangerous and some was not, we have to follow the actual disease cycle. The major waterborne killers are fecal-oral pathogens. They live in the human gut. They leave the body through feces. If that feces reaches the water supply, the pathogen gets into a new person. That person gets sick, produces more contaminated feces, and the cycle accelerates. This is why dirty water often really means water contaminated by human waste. It is not the dirt, it is us. Animal waste also matters. Animal feces can carry parasites and other microbes. But the diseases that shaped cities, cholera, typhoid, dysentery, are primarily human. That is why the number of people in one place is so important. For most of human history, before agriculture, this cycle was hard to sustain. Hunter-gatherers lived in small groups. They moved around. Their waste was scattered over a large landscape. They did not have permanent latrines next to a river. They did not have thousands of people sharing one water source. That does not mean their water was always pure. Parasites and animal waste existed. But the specific nightmare of cholera and typhoid in dense settlements was less common. There were not enough people close together to keep the cycle going. Farming changed that forever. Around 10,000 years ago, people started staying in one place. They had to. Crops do not move. So they built houses, stored grain, and created permanent villages. They also created a new problem, a lot of human waste building up in the same area, often near the same river or stream they drank from. The first agricultural settlements were not just the beginning of civilization, they were the beginning of the urban sanitation crisis, and every city since then has been trying to solve it. Geography was destiny. A mountain settlement with a clean spring had a huge advantage. A city on a swampy floodplain faced chronic problems. People didn't always know why, but they could see that some places were healthier than others. That is one reason certain springs became sacred. If a spring never seemed to make anyone sick, people built a temple there. The water was not just holy, it was the best water available. The first great solution was probably the well. A well is easy to underestimate because it is just a hole in the ground, but a deep well taps groundwater, and groundwater has been filtered by soil and rock. Soil is not a perfect filter, but it is a remarkably effective one. As water seeps downward, particles, including many pathogens, get trapped or die off over time. A well that goes deep enough can bring up water that is much safer than the river at the edge of the village. Ancient people did not know about filtration, but they did know that well water tasted better and did not make them sick as often. You can think of a well as a time machine. The water you pull out may have fallen as rain years ago, then spent a long time moving slowly through layers of sand, gravel, and rock. During that journey, many of the organisms from the surface died off. Not all of them. Groundwater can still be contaminated, especially if a well is shallow or placed too close to a latrine. But the risk was lower, and ancient people learned to keep wells away from waste. In the Indus Valley, more than 4,000 years ago, cities like Mohenjo-Daro had brick-lined wells, bathing platforms, and covered drains running under the streets. They were separating clean water from wastewater. That is not the behavior of people who were indifferent to filth. That is civil engineering. The Romans took the same idea and scaled it up. Rome had access to clean springs in the hills, but the city grew too large for local water, so they built aqueducts. The part of an aqueduct you see is the big stone arcade, but most of the system was underground. It was a gently sloped channel, carefully engineered so that water flowed by gravity for tens of kilometers. This was not just a way to move water, it was a way to choose water. They were not pulling from the Tiber, which received the city's sewage. They were bringing in water from clean, high-elevation sources. Roman engineers kept the water flowing at a precise gradient. If the slope was too steep, the water would erode the channel. If it was too flat, it would stagnate. They built inspection shafts, settling basins, and distribution tanks. The water was not treated in the modern sense, but it was chosen, protected, and moved with care. By the early empire, Rome had multiple aqueducts delivering millions of liters per day. The water went to public fountains, baths, and some private homes. It also fed the sewer system, which pushed waste away from the city. The Romans did not have germ theory. They thought they were building an incredibly nice public amenity, but they accidentally built one of the most important public health systems in the ancient world. The result was that a city of roughly 1 million people could exist without collapsing from its own waste, most of the time. Of course, we should not romanticize Rome too much. Lead pipes, water theft, and sewage in the Tiber were real problems. The aqueducts delivered clean water, but not everyone had equal access. The rich had private connections. The poor used public fountains. Yet even that public supply was better than drinking from the river. The same logic appeared in Persia. Engineers built qanats, gently sloped underground tunnels that tapped into aquifers and carried water to settlements. The water was naturally filtered by the earth. It was, in effect, a man-made spring. In Egypt, some people used alum to make suspended particles settle out of water, clarifying it. In parts of India, medical texts recommended boiling water, filtering it through sand and charcoal, and storing it in copper, or exposing it to sunlight. That is surprisingly close to modern emergency water treatment. They did not know why it worked, but they could see that it worked. So why do we have the myth that everyone drank beer or wine instead of water? because some of them did drink a lot of beer and wine. But the reason is more interesting than water was poison. Ancient beer was not strong enough to sterilize anything. Most ancient beers had low alcohol content, maybe around 2 to 5%, sometimes less. A person could drink it all day without being drunk. But the brewing process involved heating water and grain. Depending on how it was made, that heating could kill many of the pathogens in the water. Fermentation also made the liquid more acidic and less friendly to some microbes. So beer was often safer than raw water from a busy river, not because the alcohol killed the germs, but because the process had already cooked and transformed the water. In ancient Egypt and Mesopotamia, beer was often thick and soupy, more like a fermented grain porridge than a modern lager. It was brewed from barley or emmer. The water and grain were heated during preparation. That did not always mean a full rolling boil, but it did reduce the microbial load. The beer was then consumed relatively quickly, before it could spoil. It was a staple food as much as a beverage. Think of it as liquid bread, with a safety side effect. It was calories first, hydration second, and sanitization as a lucky byproduct. Wine had a similar, though imperfect, effect. The Greeks and Romans usually mixed wine with water. Drinking unmixed wine was seen as barbaric. That mixture was not sterile. The alcohol was too diluted to kill most pathogens quickly. But wine's acidity and some of its antimicrobial properties may have helped slow spoilage. If you were storing water on a ship for a long voyage, adding wine could keep it palatable and perhaps a little safer. It was not a magic shield. It was a risk management tool that also happened to taste nice. But here's the part that often surprises people. Most ancient people still drank water. Plain water. Every day. Beer and wine were important, but they were not a replacement for water. The idea that everyone in the past was mildly drunk all day is a modern fantasy. If every Egyptian laborer, Roman soldier, and Chinese farmer had been intoxicated from breakfast to bedtime, not much would have gotten built. Water was always the baseline, especially if you were poor. Beer and wine sometimes had social, religious, or economic roles, but they were not the primary hydration for most people. Some of the best accidental water safety came from hot water. In China, the habit of boiling water for tea became widespread more than 1,000 years ago. People did not know they were killing bacteria. They knew tea tasted good, provided stimulation, and was believed to aid digestion. But every pot of tea was also a pot of water that had been heated enough to kill many pathogens. In a dense city, that mattered. It may have saved millions of lives over the centuries without anyone realizing it. The Chinese relationship with boiled water deepened during the Tang and Song dynasties, when tea became a cultural institution. Boiling water for tea became standard. The water might be boiled for flavor, but the effect was to kill many of the pathogens that caused gut disease. This may be one of the underappreciated reasons that Chinese cities could grow densely while remaining relatively stable. It was not the tea leaves, it was the temperature. Similar habits appeared elsewhere: soups, broths, herbal infusions. Any culture that regularly consumed heated water got a quiet public health benefit. It was not planned, it was just a preference for hot liquids. There were also subtler technologies. Some ancient cultures stored water in copper or silver containers. We now know that copper and silver ions can kill many bacteria and algae. Ancient people did not know that. They just noticed that water kept in a copper pot did not go weird as fast as water kept in a clay jar. They may have thought the metal had a special property. They were right, just for the wrong chemical reason. But all of this, wells, aqueducts, beer, tea, copper pots, was not enough to make ancient water safe by modern standards. That is the second big correction. The question, why didn't ancient people die from dirty water, assumes they did not. They did. Constantly. Especially the very young, the very old, and the already sick. Diarrheal disease was probably one of the greatest killers of children in the ancient world. It did not always create dramatic historical moments. It did not burn down cities like war. It just produced small, private tragedies, repeated over and over. Ancient life expectancy was low, largely because so many children died. Waterborne pathogens were a major part of that. The worst outbreaks could be catastrophic. Cholera, for example, can kill a healthy adult in a single day by causing the body to flush out water and electrolytes. In a dense city with a shared water source, an outbreak can spread explosively. Ancient medical texts describe diseases that look very much like cholera and dysentery, sudden, violent, and often fatal. They did not know the cause, but they saw the pattern. Some survivors had partial immunity to local pathogens. If you survived childhood in a particular village, your immune system had likely seen some of the local bacteria and could mount a faster defense. But that immunity was not a superpower. It was specific, partial, and bought with suffering. A traveler from another region could arrive, drink the water, and be dead in days. That is another reason ancient people were suspicious of unfamiliar water. It was not just snobbery, it was self-preservation. This is also why travelers' diarrhea is not a modern inconvenience. It is an ancient immune mismatch. The locals had adapted to the local gut pathogens. The newcomer had not. So why did they not realize the truth sooner? Because the real cause was invisible, and the delay between drinking bad water and getting sick made it hard to connect cause and effect. If you drink contaminated water today and become ill tomorrow, you might blame the heat, the air, the gods, or something you ate. Ancient people developed a theory that foul smells, miasma, caused disease. It was incorrect. But here is the strange part. It worked. If you believe bad air is dangerous, you will probably clean up waste, build drains, and avoid swamps. The wrong theory produced the right behavior. The Romans built the Cloaca Maxima, a massive sewer, to drain waste away from the city. They did not do it because they knew bacteria lived in feces. They did it because the city smelled bad, and they believed that smell was dangerous. They were wrong about the mechanism, but right about the outcome. Removing waste from the streets also removed it from potential water sources. Many cultures developed similar rules about purity, washing, and waste disposal. Some religious codes required people to wash after contact with excrement, to bury waste outside the settlement, or to avoid certain foods. These rules were not written as public health policies, but they had the same effect. They reduced the chance that fecal matter would end up in the water. Over time, the cultures that maintained such habits were more likely to survive in dense settlements. No one needed to know about germs. They just needed to behave as if filth was dangerous. There's a deep irony here. The modern idea of hygiene was built on wrong theories and practical habits. We did not start with a correct understanding and then build sewers. We built sewers because we hated the smell, and the correct understanding came later. The big formal discovery came much later. In 1854, London had a cholera outbreak. A physician named John Snow mapped the cases and noticed they clustered around a single water pump on Broad Street. He persuaded the local council to remove the pump handle. The outbreak declined. Snow did not discover the bacterium. That took decades more. But he demonstrated in a modern city what many ancient people had already learned by trial and error. Water could carry disease, and the source mattered. Later, investigators found that a nearby cesspool had leaked into the well. That was the moment a modern city empirically confirmed an ancient intuition. The pump was popular because its water tasted better than other sources, but it was contaminated with human waste. The modern water treatment plant is the descendant of that insight. We use filtration, settling, disinfection, and testing. We can see bacteria. We know exactly which pathogens cause disease. But the basic principle is ancient. Separate human waste from drinking water and prefer clean sources over contaminated ones. So why didn't ancient people die from dirty water? They did, but our species did not just sit in the filth and hope. We used disgust to avoid the worst water. We learned that clear springs and deep wells were safer. We built aqueducts and drains to keep waste away from drinking water. We accidentally made water safer by turning it into beer, tea, and wine. And we developed cultural habits, some religious, some practical, that kept human waste away from the water supply. None of it was perfect, people suffered, but those practices were enough to keep civilization going. Next time you fill a glass from the tap, you are not just using modern technology. You are using the accumulated memory of every civilization that noticed, sometimes at terrible cost, that water is most dangerous when it has been near us. The difference is that now we do not have to guess. Ancient people did not need to know what a bacterium was. They just needed to know which water to trust. Most of the time, that was enough. Until it wasn't.